And here we are, 6.1, psychopathy, and let us do part 2. I promise you a cliffhanger. You say, well, these damn psychopaths, they're just not empathetic. They hurt people without regard for their feelings. We need to teach them empathy. The problem is, and what people generally find, is when we teach psychopaths empathy, what they learn is how to become better psychopaths. They don't become empathetic. But they understand then how to manipulate your empathy more successfully. So empathy training for psychopathy is kind of controversial, and most people are not on board because it just adds a tool to their toolkit to manipulate us to a greater degree. Now, measuring empathy, the interpersonal reactivity index was developed by Davis. There is a book by Davis called Empathy, Mark Davis. Cool book. A nice read. He writes really well, and he does have his interpersonal reactivity index in that book. So if you're interested in going that route, you can also Google the interpersonal reactivity index, and I'm pretty damn sure you can find it. So this is a great measure of empathy. For those of you who want to kind of really do double duty on your paper for this class, and you're choosing emotional intelligence, you could also incorporate or include the interpersonal reactivity index, because notice that empathy is really a central quality to emotional intelligence, right? So, or at least high emotional intelligence, let's put it that way. So, measuring empathy, you can measure autonomic responses, that is skin conductance, expose Confederates being shocked, or show images of distressed individuals. And for those of us who are more empathetic, I'm not crazy about the term empathic, but then I love Star Trek, so empaths to me are like Deanna Troi in Next Generation. Whole different world, right? But those of us who have higher levels of empathy will respond more readily and to a greater extent to watching the distress of others. And this can be measured in the galvanic skin response, that is the skin conductance. That is, we perspire under those conditions, so the surface of our skin facilitates the conduction of electricity across its surface. Both show lower levels of responsiveness, right? So, naming observed facial expressions is another way to get at this. And since we had this task, I think it's kind of funny and cool, right? So you name and observe facial expressions. Controls identify at 65%. Psychopaths identify at 75%. You say, well, this sounds like psychopaths do better. And no, what this means is this is wacky. You know, the computers have facilitated a lot of our research. And what happens is we take a picture of a person with a neutral expression, and then we say, okay, we want you to do a sad expression. And we take those two images, and with the proper computer software, what we can do is then have gradual morphs, right? So this is... the next expression is not neutral. It's 10% from neutral towards sad, right? 20%, 30%. So the computer can morph the two images and create these very interesting expressions. Control participants identify correctly at the 65 level. Psychopaths need more on average information. That is, the expression has to be closer to the target expression at 75%. And this is pretty cool. Thank God you have the lecture notes, so you might be able to see this. But you can see this is neutral to anger morph. So here's the neutral face, and there's the anger. And these are the computer generated in between. Here's neutral to fear morph, right? And fear to anger morph if you really want to mix it up and make it special. So bless computers for giving us the ability to study these things in ways that people 50 years ago would have never dreamed of. I guess someone could have employed an artist to make all those interim sketches, but can you imagine how time-consuming that would be when we have a computer that can do it in short order? So, let's talk about the fear dysfunction hypothesis of psychopathy. Psychopaths are less aversely aroused by punishment. So under conditions of punishment, less arousal, and that means that in fact punishment is likely to be less effective. So they make weaker associations to punishment-evoking stimuli. And notice it could be a double whammy. It could be because they have weaker associations, or they have weaker associations and they're less aversely aroused. So two components. Counter-arguments? Well, there appear to be variants of this hypothesis that aren't very well explained at the cognitive level and at the neural level, but we might go back to differentiating psychopathy as being primarily factor 1 or primarily factor 2, and does that explain the observed difference? Maybe, maybe not. I wonder if there's some of you watching this, I would normally say some of you in the classroom, who might be contributing to the answers of these questions in your career down the road. Right? One thing that we have to deal with, and this is one of the reasons I love studying emotion, because there's so many unanswered questions, right? It's unlikely that there's a unitary fear system. Maybe the fear system is comprised of multiple mechanisms throughout the brain. Maybe when we're super skillful, we'll actually differentiate between different types of fear. Wow, if that's possible at all. Okay? It isn't really clear why the fear dysfunction should show increased antisocial behavior. Right? Moral socialization functions through empathy rather than fear. Interesting. Well, notice also, I just read an article, I think it was yesterday, that they were looking at elements of empathy and psychopathy as it relates to mask wearing. And what do you think, wearing masks, what might your predictions be about the relationship of those qualities? Kind of fascinating, right? But this moral socialization through empathy rather than fear, according to Hoffman, I think, remember what Hobbes said about fear. Fear is the mechanism to maintain social order. So I don't think Hobbes would agree. But then he doesn't have to, right? And we're good with processing multiple perspectives, right? Because we're critical thinkers. We can say, well, this is possible, but that's possible as well. And then that leads us to try to understand how we would develop evidence to support multiple or different hypotheses, right? So let's talk about Gray's behavioral inhibition system. I want to give you a quick example. Imagine, and I've seen this, I've felt this happen, and I bet you've felt similar things happen as well. I hope you have, right? Cast iron skillet on the stove, right? There it is. It's good and hot, right? We're going to blacken some fish, let's say. And that pan is hot, right? And what happens to the handle of that cast iron skillet? Well, iron transmits heat pretty well. That handle's going to be as hot as the skillet is. So here I am reaching for the skillet, and all of a sudden I stop. Something just shouts in my head. My non-conscious goes, stop! Because through prior experience and prior training, I know that handle is hot. So the behavioral inhibition system, the behavior is reaching for the skillet. The inhibitory process shouts stop, so I don't actually grasp it and burn my hand. Right? And Gray developed this, circa 1982. So things like signals of punishment, signals of non-reward, novel stimuli, or in the case of the pan, probably innate fear stimuli, all serve to activate the behavioral inhibition system. So this is essentially, typically with the BIS, the behavioral inhibition system, the BIS, right, the BIS, these are often processed non-consciously. They're aspects of the environment we're not necessarily attending to. The behavioral inhibition system, largely non-conscious, screams at the conscious, stop that movement, stop what you're doing, as a protective device. And you can see how adaptive the BIS could be in prolonging our life, right? Allowing us to adapt to threats in the environment, right? And then what is the output of the BIS? Behavioral inhibition, so I stop reaching for it. I stop short of actually touching that handle, right? Note that it can also increase arousal, so maybe I hear a sound, and there's an old advertisement for Colt firearms way back in the day, way back in the 1960s. They were trying to sell a pistol, right? And they said, it was super simple. It shows this guy sitting by a tree in the dark, just by himself out in the woods. And it's a snap twig, colt confidence. But it's that snap twig, you know, when you hear that noise. What was that? That noise, right, that causes the increased arousal. So, or our autonomic nervous system is being kicked into gear. It's kind of that stress response. And notice it increases our attentional capacity as well. Highly adaptive, highly facilitative. Notice it can go wrong with anxiety disorders, etc. Now, how do we know part of the how this system works? Well, guess what? If you give people anti-anxiety drugs, then it diminishes the responsiveness of the behavioral inhibition system. So another way to test it. So this is just inhibiting behaviors that might be damaging to the organism. Now I want to show you another model, but this is a more specific model. This is, where to go, the violence inhibition model. So now, what does it take for us to inhibit violent responding? So a stimuli has caused us to, we've processed it in such a way that one behavioral response might be to commit violence against a stimuli. So what we see then is transgression representation. So there's some kind of moral transgression that's taken place, right? We see distress cues potentially. Someone is sight and frad, faces or sounds, right? And then these can then turn on the violence inhibition mechanism, causing us to stop short of participating in an aggressive act, right? So the violence inhibition mechanism then, freezing or avoidant behavior and or reactive aggression is necessary as one potential output, right? But other potential outputs, the violence inhibition mechanism, another route it can go is to increase our arousal, increase our attention. So notice, it is kind of consistent with the BIS. Do these systems overlap? How can we know at this point in time? We really don't have the methodology to figure that out, what their association is. But increased arousal, then the experience of moral emotions such as guilt and sympathy are part of this appraisal mechanism. Now, understand that some people then simply just don't have an elaborate VIM, violence inhibition mechanism, and these are people who demonstrate higher levels of reactive aggression or instrumental aggression, but especially reactive aggression. Now, we know that when we look at these models, we're going to eventually have to understand how they're represented in the brain. I mean, that's where we're going, and that's why neuroscience is the bomb right now. Neuroscience is the place to be for funding, but also for untangling a bunch of theoretical messes that we're in the middle of that we just don't have the tools yet to study, and neuroscience is a big part of the promise there. Right? So what about the left hemisphere then? And people make big deals about hemisphericity. I don't know. I don't know enough. I'm not a neuroscientist, so that's when I get into these areas, it's like, it's getting a little shaky on this ground here. Potential exists. The language processing facility in left hemisphere is weaker in psychopaths. So we know that we have Broca and Wernicke's areas in the left hemisphere, right, and facilitate language processing and language production, right. This seems to be weaker in psychopaths. And one way that they study this is the dichotic listening task, right? And what that is the dichotic listening task. You put on the headphones, but dichotic means two. So there's two signals, two different signals, right, that you need to attend to in the two different ears. And what this does is allows us to see which area of the brain might be more dominant. So we see deficits in right ear processing in psychopaths, but not in the left ear. Let's read that again to make sure we understand it. So we show deficits in the right ear, which is being processed by, yes, you know it, the left brain, right? And the left ear is being processed by the right brain. So that's supporting evidence for their contention there. Cosson goes on to investigate levels of left hemisphere interference during complex tasks. The left hemisphere activation hypothesis gains some empirical support consistent with Hare's findings. Okay? Now, causal mechanism, general underspecificity lead the hypothesis with little real support. much more to be understood. Notice, when we start looking at brain research in this regard, we go, is the difference we observe at the neural level the result or the cause? And again, then we could offer both, or remember, anytime anyone offers you a forced choice, is it this or that, you could also respond, well, it might be both, or it could be neither. So any forced choice response that someone's trying to shove at you, when you're a critical thinker, say, well, it could be this or it could be that, but it could be both, it could be neither. Remember, there's always 4 responses. Be suspicious of people who want to force you into an either or. So, frontal lobe dysfunction hypothesis is another place we can look. The frontal lobe is a source of executive function and inhibitory processes. That's pretty damn well accepted. And we see that as a result of frontal lobe damage and or lesions, then we see the loss of inhibitory power. This is one of the components of dementia, is loss of frontal lobe ability that then manifests itself in the elderly's inability to control impulses to the extent they could previously. When our old folks are saying whatever pops to mind, we used to say, well, they just feel they're entitled to because they've lived so many years. And no, it's more likely that they have inhibitory process failure. The ability to inhibit processes is diminishing, and so this shit just pops out of their mouth, right? So lesions in the frontal lobe have been implicated in emotion changes, personality changes, changes in aggression. Go back to Psych 1100. Remember the guy, what was his, Phineas Gage, got the pole put through his head, right? And we see him become an aggressive responder. Increased aggressiveness is typically in reactive aggression rather than instrumental, which requires planning. And notice the planning requires foresight. And we could argue that we would see the instrumental aggression potentially diminish under these circumstances, although I don't know that that's been researched. So there does appear to be a function, a connection to the frontal lobe dysfunction in psychopath, and it seems to be connected to the orbital frontal cortex as it relates to executive function. So psychopaths might process their world differently, right? It's been supported by lessened cerebral blood flow that might reduce PFC functioning, okay? And again, there's so much more to be done. This is wide open territory for you guys who are interested in researching these areas, right? So these are starting points in the understanding of the causal mechanism. Is by no means the end of the story. Now, let's talk about the somatic marker. So Damasio, right, says when confronted with stimulus that's associated with rewards or punishments, the bioregulatory states bias the individual towards response options. So that, in fact, stimuli, through this somatic marker hypothesis, remember, stimuli become associated, that is, actual sensory tags are placed on stimulus on the basis of our experience. So it makes approaching pleasant stimuli the way to go and avoiding negative stimuli, right? So essentially response options are biased by bodily feedback, or these somatic markers. I imagine, and again, a lot of theorization, a lot of research could be done about this, but note that some very simple creatures might learn that certain stimuli represent painful experience, you know, at a physiological level. So these species then learn to avoid those. And things that feel good, then they move towards, right, that they seek out. So the mechanism is, you know, kind of well supported in other regards. So they're processed through the somatosensory cortex, and thus labels automatically a scenario or an element, a stimulus object, right, as either positive or negative. That is, bringing pleasure or not, and affects the choice of the response option. That is, greater response options approaching pleasure, greater response options avoiding pain. Now, participants with lesion to the ventromedial frontal cortex, right, the VMFC, if you will, we know that neuroscientists like their abbreviations, demonstrate no autonomic response to images in passive tasks, simply viewing disaster, but do show autonomic arousal under active viewing conditions to the extent participating to a greater extent. Now, let's finish up with the somatic marker hypothesis. 4-pack playing card tasks. And this is another laboratory paradigm to share. Participants learn to discriminate between one pair of decks that are high reward and high loss as opposed to the other pair